Hi everyone, this is Dinakaran, Department of Computer Science and Engineering, Rajalakshmi Institute of Technology. Today we are going to discuss about the topic clustering techniques in data mining. Uh, Already we discussed about what is the classification. Classification is a supervised learning method and clustering is an unsupervised learning method. Various applications nowadays we are using in the field of data science, data analytics, and various types of data related techniques. The classification is for different types of algorithm we are using, like decision tree methods, Bayesian classification, support vector machine, and many types of algorithm. Then this is a continuation of the last session. So we are going to discuss about clustering techniques. So clustering techniques is one of the technique. It is also called as unsupervised learning. So today's topic we are going to discuss about clustering techniques in partition based clustering. So clustering techniques has been studied extensively for past 4 decades and across many disciplines due to its broad application. As a result, many clustering techniques have been reported in the literature, and also this is a categorization of various methods we are going to study about in the area of clustering. A broad taxonomy of existing clustering methods shown in the following figure we will discuss. Then it is not possible to cover all the techniques in this lecture series because it will take it's a lot of time to discuss all the applications and algorithms. So clustering technique basically categorized into 5 types of clustering. One is partition method, hierarchical method, density based method, graph method, and model based clustering. The first partition method, the basic 4 algorithms. One is called k-means algorithms and k-medoids algorithms, k-modes algorithm, and fuzzy c-means algorithm. And k-medoids algorithm is categorized into 3 types: PAM, Clara, and Clarence. So these are the techniques for using for partition method. Then second one is called hierarchical method. The hierarchical method is categorized into 2 various types of methods. One is called divisible and another one is called agglomerate method. Divisible will categorize into one type that is called Diana, and Agnes, Breach, Cure, Rock, and Chamlons are agglomerate clustering algorithms. Then density based clustering, it will be categorized into 6 various types, and graph based method is categorized into 3 types, and model based clustering is categorized into 4 types. These are the things we will discuss on upcoming sessions. Today we are going to discuss about partitioning method. In partitioning method, the basic algorithm is k-means clustering algorithm. A k-means clustering algorithm proposed by Hartigan and Wong. They have proposed this algorithm on 1979. It is purely based on n distinct object. The k-means clusters algorithm partitions of object in k number of clusters such that intra-cluster similarity is high but intra-cluster similarity is low in the k-means algorithm. What is actually intra-cluster and intra-cluster? So it means that it is basically calculated based on the distance of the nodes which will be formed in the same cluster. So how the nodes are communicating with one cluster to another cluster, or how it will be grouped to one cluster to another, which will be based on the distance. And in this algorithm, user has to specify that k, the number of clusters, and consider in the object are defined with numeric attribute, and thus using any one of the distance metrics and the matrix get the clusters. So this is a algorithmic procedure how the clustering is happening in the technique. So input is D, capital D is denoted at the data set containing in the n number of object, k is the number of clusters. Then output of the cluster is a set of k clusters. Then a first step, how we can randomly choose a k object from the data set D in the initial centroid clusters. For each of the object in the data set, then compute a distance between the current object and k cluster centroids. Then next step is assign the current object to that cluster to which it is closest. Then again compute the cluster centroids for each clusters. This becomes the new cluster centroids. Repeat the step 2 and 3 until the convergence creation is satisfied. So this is what the basic procedure how the k-means clustering is working in the data sets. Then this is a problem we are going to discuss. Cluster the following 8 points with x, y representing the location into 3 clusters. The 3 clusters are randomly generated as I said in the previous stepwise algorithm. Then the point 1 is A1, A2, A3, A4, A5, A6, A7 and A8.
The initial centroids are, this is what the randomly picked. A1 is 2, 10, A4 is 5, 8 and A7 is 1, 2. The distance function between the 2 points A equal to x1, y1 and B equal to x2, y2 is defined as P of A, B modulus of x2 minus x1 plus modulus of y2 minus y1. So we are going to solve the problem using the K-means algorithm. So this is the iteration 1. In the iteration 1, we have a tabulation. The table will consist of number of points. What are the points given in the problem? And first one is called the mean 1 and distance mean 2, distance mean 3, and which cluster is this? So 2, 10, 5, 8 and 1, 2 are randomly chosen cluster centroids. And first we list out all the points in the first column of table. The initial cluster centroid means 2, 10 and second one is called 5, 8, third one is 1, 2. This is what you send randomly, as I said already. Next we will calculate the distance from the first point 2, 10, each of the three means by using the distance function. The first point 2, 10 and second one is called 2, 10, which is what 2, 10 and this 2, 10. x1, y1 and x2, y2. x1 is 2 and y1 is 10. x2 is 2, y2 is 10. This is in the previous tabulation. x1, y1 and x2, y2, the same values. Then P of A, B equal to modulus of x2 minus x1 plus y2 minus y1. Then we are going to apply the values 2 minus 2 plus 10 minus 10. So plus 0 plus 0 equal to 0. So we are getting the value 0. Why we are using the modulus here? We need the positive values in the given K-means problem. So for that they are using the modulus. Then second point 2, 10, 5, 8. In the previous tabulation 2, 10, again they are going to apply the second centroid 5, 8. Then again we are going to apply a 6 x1, y1, x2, y2. Do the computation. We are getting the value is 5. Then third point 2, 10, apply the third centroid value in the problem. Then simply directly we are going to apply it x1, y1, x2, y2. Then 1 minus 2 plus 2 minus 10, 1 plus 8 is the value is 9. Since the value is for the first centroid is 0, second one is 5, the third one is 9. How we are going to return 1. So we calculate the distance, as I said in the first rule, calculate the minimum distance. So 0 is comparatively minimum of 5. So 9 is also 0 is the minimum value. So this is going to fill the value in 1. So directly we taken it is a cluster 1. So which cluster should be the point 2, 10 be placed in? The one where the point has shortest the distance to the mean, that is the mean 1. That is what the cluster 1, as I said, it is 0. In 2, 10 will be placed there. So we got the second point 2, 5 and we will calculate the distance to each other. 3 means by using the distance function. Again we are going to apply the second point in the given problem. So this is what the second 2, 5 with 2, 10 and 5, 8 and 1, 2. x2 minus x1, x1 y1, x2 y2, x2 minus x1 and y2 minus y1. Directly we apply the value, we are getting the value is 5. Again for the second point 2, 5 with 5, 8. So just apply the value, we are getting the value is 6. Then the third value 2, 5 with 1, 2. So we are getting the value 4. You just fill the value 5, 6, 4. So here 5, 6, 4. 4 is the minimum. It's a minimal value comparatively with the other two values. So we can write it here. The cluster is 3 is the minimum value. The distance is minimum comparatively with the other 2 points. So here place a cluster 3. Then apply 8, 4 with all 3 values, 5, 8 with all 3 points, and 7, 5 with all 3 centroids, 6, 4 with all 3 centroids, and 1, 2 with all 3 centroids. Then finally 4, 9 with all 3 centroids. So we are getting the value for each. Which one is minimum? For the third iteration, the minimum is 7. So we written here is cluster 2. For the fourth iteration, we have the value is 0 is a minimum. So cluster 2. Again, the fifth iteration, 10. Which one is a minimum? 5 is minimum. It will responsible for a 2. Second cluster again 6. Sixth value 5 is a minimum. It's for cluster 2. Again, the seventh one is minimum is 0. It represents the cluster 3. Then eighth value is 2 is a minimum, so we are going to write it here 2. Then this is the final value, cluster 1, cluster 2 and cluster 3. There are 3 various types of clusters we already randomly chosen from the given problem. 2, 10 and 8, 4, 5, 8, 7, 5, 6, 4, 4, 9. Just we are going to write this value. 8, 4, 5, 8 and 7, 5, 6, 4, finally 4, 9. Then for the third cluster, second row, 2, 5, again it's a 7th row, 1, 2. 2, 5 and 1, 2. Next we need to recompute the new cluster centroids, because our ultimate objective is we need to find out the actual centroids in the given for the cluster. So for the cluster 1, we have only one value that is also picked as a random value. So the same values remains in the cluster centroids. Again cluster 2, we have 5 values. So for all x and for all y, we are going to add all the x divided by number of values and all y's divided by number of values. Just we are going to compute this 8 plus 5 plus 7 plus 6 plus 4 divided by 5 and 4 plus 8 plus 5 plus 4 plus 9 divided by 5. So after the computation we are getting the value 6, 6. That is the second centroid. Then third one is we have 2 values. This is with respect to x and with respect to y. So 2 plus 1 divided by 2, again 5 plus 2 divided by 2. So we are getting the centroid is 1.5 and comma 3.5. So this is what the first initial step. What are the points they are given in the problem? So we just point it here, and this is a randomly chosen centroids. So that will be marked in the randomly chosen centroids. Again we are going to do the computation. We are getting 3 new centroids, right? That new centroids are marked in X red colors. So existing centroids are marked in normal X dotted. So what is the value we are getting here? So that will be grouped together, and finally it will be make up 3 clusters as well as 3 new centroids. The initial cluster centroids are shown in the red dot, that is what I said. The new cluster centroids are shown in red X. That was iteration 1, that is epoch 1. Next we are going to do the iteration 2, iteration 3 and so on. We are going to do the iteration continuously. When we are going to stop the iteration, we basically repeat the process from iteration 1. This time using the new means we computed. Then again we are going to do the iteration. Then finally we are getting another one more centroids value for iteration 2. So we are getting the centroid values 3, 9.5, 6.5, 525. Third centroid is 1.5, 3.5. Just we are going to mark it here. Same X red colors. Again this third iteration we are going to do, we are getting another 3 various types of centroid. It is closely for the same values. So we can stop the iteration from here. So there is a centroid is 3.66, 7, 433 and the third centroid is 1.1, 35. So this is what the final clusters for A7, A2 is a cluster 1, A1, A8, A4 is the second, and respectively the third set clusters. Thank you. And one more thing I want to share here, where are the applications they are using in K-means clustering. One of the major application is finding the crime locations. So how they are going to finding the crime locations based on the distance and where the data actually they are going to share. So the crime locations is grouped based on this K-means clustering algorithm. Thank you.